Hello everybody and welcome to this video where we'll be grinding leetcode. So as a bit of context, I've been going through this course on YouTube, and I've been making some notes in Notion, and for example contains duplicate, and then we have a different hash map. Well, we have a different solutions, so yeah, like this. But what I've been doing is I've kind of been looking at the solution, like kind of understanding the main concept, but then just not writing out the code myself and just pasting it into Notion. So what I want to do is I want to continue this YouTube course, but first I want to consolidate all of these ones so that I'm not getting behind, and make sure I'm familiar with all the different ways you can solve a problem with the two pointers technique, hash maps, etc. Okay, why not? Let's start with threesome. So I'm just gonna do it on this paper, and I've got a page here for pasting images, so I can take a picture of my phone, and then you can see it on the screen. So I'll just talk through my intuition, as I've put my intuition here. Sorry. Okay, so let me just get threesome up. Leetcode. Okay, so let's get the problem. We'll just use a sample array and then we'll go through it. So this will be threesome. One is 15. So given an integer array nums, return all the triplets nums at I, at j, at k, such that I is not equal to j, and I is not equal to k, and j is not equal to k. So the solution must not contain duplicate triplets. So this is one that I had to go at, which is using the way in which you need to do it. So I'm just going to go through this on my piece of paper using this sample input example 1. So here we have the -1, 0, 1, 2, -1, and then 4. No, sorry, -4. So what we're going to do first is we're going to sort this array, because this will be important for doing it. So this then gives us, let's see, so we've got -4, -1, -1, 0, 1, 2. So after we sorted our array, so this one here, then we'll have a counter I. So this counter will go through, so it will have every index in the array. So we'll go for I in range len r. So at the minute this is just like kind of pseudocode. So we go through it and we have our I index. So at first I will be here, and in this loop we're going to initialize j, which will be the index just after I, and k will be the last index. So equals len r -1. So after we've initialized these, we want to keep changing. This is the two-pointer technique. Keep changing j and k so that we find when these three numbers add up to 0. So we're going to do while j is less than k. So for example, so say we've got our array. Okay, let's just start simple. 1, 2, -2, 1. No, sorry. Okay, all that wouldn't work. Then 3. So say we have an array 1, 2, -2, -1, 3. We would have our I at position 1, and then that's right. And then j would be at position 2, and then k. Let me just index all of these. So 0, 1, 2, 3, 4, and k would be at index position 4. So what we want to do is, as they're sorted, so let me just sort this array real quick. So -2, -1, 1, 2, 3. So here I, j, and k. So the rationale here is that we start off with I, and we sum all of them together. And if they're greater than 0, then that means we want less numbers, less numbers added together. So we decrease k because it's like a smaller number. So sorry, I don't mean less numbers. I mean smaller numbers added together. So if I plus j plus k is equal to is greater than 0, and then we decrement k. But if LF I plus j plus k. Oh, so no, we would need to index these. So num sub, and then do that for that, and num sub for that, and for that. So if it's less than 0, then we just need to get a bigger number. So that's why we'd increment j. Sorry. Yeah, and then else it'll equal to 0, so we can append this to our result. So I, j, k. So this is the 2-pointer technique. And this, so I'll just walk through it on a sample array. So I'm sorry I'm not doing this on the screen, but I'm just trying to, I just think it's easier for me because I don't have like a pen or something I can use. Okay, so we've got our array, -4, -1, -1, 0, 1, 2. So we start off at I here, j here, and k here. So this adds up to -3. We'll just have a tally here. So what we need to do is we need to get a bigger number. So we replace j to index position 2. So j would be here now. So now this, okay, it's the same. So we also need to increment j. So this here would be -2. We still need to increment j. So j is here. And this would still be -1. So we've reached our end where if we increment it, the j minus k condition will no longer hold true. So what we've got to do is we just got to increment I, because this while loop will for some reason though this code isn't working at the minute, and I need to fix this. Okay, so then we increment I to position 1, and then we initialize j and k again. So here we've got -1 plus -1 plus 2, and this adds up to 0. So we would append. We are not appending indexes. So -1, -1, and 2, and then as we've got that, I think we just increment. Do we? Yeah, we would just increment. Actually, no, because never mind, because that will go on the second round. Sorry. So we've got one of these, and now let's reset our positions. I'm just going to draw this array out again. Okay, 0, 1, 2, 3, 4, 5. So now I will be here, j will be here, and k will be here. So this adds up to a larger number, so we'll decrement k. This adds up to 0, so it'll be -1, 0, and 1. And I think that's all the numbers. Yeah, okay. So that is how we would solve 2sum. 2sum is just basically a hash map storing the difference. It's much easier than this. You don't have to use the 2-pointer technique. So I'm just going to take a picture of this so you can see it. My computer camera isn't the best, so that's why I'm going to need to do it this way. How am I going to take a good picture of this? Okay, too much of a shadow. Fine, I'm just gonna have to go like this. Okay, so that's that. And I'm going to upload this onto Notion. And after this, we're just going to have to fix this code because this was me trying to implement it just like 10 minutes before I started this video. So pasting images. Oh, media picker. There, here we go. It should just be uploading. It says 0%, so we can just come back to this when it's ready. Right. So now we've got 3, so I'll just show you the working here if you want to pause the video. So now we need to fix this, and like, because I think it's something to do with our while loop. We're not breaking out of it. I think it's time to ask chat. Because it's good that I understand the concept, but I need to actually note down the code. I need to find where this bug is. Okay. Reason. Oh! ChatGPT has now got the reasoning ability. Is this O3 Mini? Okay, I'm not sure. But it's now got the reasoning model, which I definitely want to use. Yeah, it's basically just copy DeepSeek. Right. Oh! What? Is it? But this shouldn't affect the while loop, I don't think. But we do need to change this. Okay. Just gonna check if it's uploaded. Okay, it's not uploaded yet. Okay, so now we've... Okay. So the issue is that it is exceeding the time limit. Okay, I'm thinking of it's inefficient. Okay, so is this not needed? I still don't think that will have anything to do with it, but actually, I suppose it's with big arrays, but it said the test case. Yeah, it was just the test case one, so. Oh, memory limit exceeded. Yikes. How? Oh, because here we need to break. Ah. My bad. Because otherwise we would just be constantly adding. Yes, here we go. Runtime 0 milliseconds. This is amazing. Okay. So at least we get 3-sum. But 3-sum is like one of the easiest medium problems. Oh. Okay. To solve this, can we just like do... Okay, what I'm going to do is I'm going to do r equals put I in result there's definitely going to be a more efficient way of doing this. So if I not in R dot append I, and then return R. Okay. Sorry, the image of, let's see if it runs. So this is just what I was originally thinking was the set function, but how? I don't get it. So for I result, yeah, if I is not in the array, we're going to append I. Otherwise, we're not. Okay. Let's see the Python way of removing all duplicates from an array. How to remove all duplicates. Because there's bound to be a function. It's going to be like dot unique. There's Python's. Oh yeah, I think I remember looking at this. It was like turning into a set, but then how do you turn from a set to a list? Okay. Okay, let's say the following array unique using a set. Okay. Oh, so we can do this. Okay, that was easy then. List set. But can you have a set of arrays? We'll have to find out. So remember last time I was saying. Okay, so this should work. 313 test cases. Still, I don't get. How are we getting duplicates when we made it into a set? I'm not sure. Okay, I'm just going to add this test case then. And nums at I, nums at J, nums at K, not in result. Okay, this shouldn't exceed any memory limits, so. And look, 0 milliseconds runtime, so it's not. Yeah, it's O log n, and yeah, O log n versus O of n squared, so we'll keep the O of n squared value. Time exceeded. So it does seem to have a large effect, apparently. Okay, let's run this again and just make sure it's working. Wait, I want to see if this because I've got this website feature, if it updates. What's the date today? Oh, it's the 1st of February already. I didn't even notice. Okay, I don't think it does. Yeah, it doesn't update, but what if I do? Okay, no, it still doesn't do it. Anyway. Expected doesn't. Oh, I'm definitely not sure why. Okay, time to give it to ChatGPT again. With this code, I get failed test case, let me just copy all this. Please fix. Okay, if not, we'll just move on because I know we're very close to the result. I just don't know why we're getting duplicates, even when we turn it into a set and then the list. Taking a closer look. No, we don't need to do it this way. Okay, so we're stopping there. Two pointers. Okay, so if we add this will skip any duplicates. But would we want to skip any? Okay, let's see. I think we'll fail a test case though. I definitely think it will. It's just on this one. The normal unhashable type list. What? How's it working before then? Okay, right, I'm just going to leave this there because we passed 56 and it shows it's just a problem with our duplicates. There's no point wasting hours on it. Right, on to the next one. So sorted array square. Oh, this was a challenging one to say the least. Okay, so sorted array square. Okay, sorted array square 977. Leetcode 977. I think this one was log n or something because there's something with the adding of the two. Because we weren't using a sort. Yeah, so this is just a brute force approach, which works, but it's like not the best. So let me just, I can't exactly remember how we did it, but it's something using absolute value and stuff. So -4, -1, 0, 3, and 10. So what we're going to do, could we just, do we split the array in half? So it's already sorted. So split array. Okay, so say we have -4 and then we have -1. I do not know why it's not uploading. How is someone going to upload it? I do not have a Word document. Okay, I just have to show it another time. 0, 3, and then 10. So I'm going to go through all of these and square them. So this will then be 16 and then 1. Then this will be 0, 3, and then 10. So what we're going to do is, sorry if I haven't explained this properly. So we have our minus numbers. We're going to split that into a separate array and our positive numbers, or the ones that are 0 and greater. And then we're going to square both these arrays, and then we're going to do a merge. So we're going to have count I and j equals 0. So we're going to do if nums1 at I is less than nums2 at j, then we're going to do final. So we're going to have final array sorry, I'm just going to square all of the values. So we're going to have our account, and we're just going to merge these two arrays together. Yeah, so they're going to be, oh no, so what I'm going to have to do is on this one, we're going to have to flip the array. Flip so that they're both in ascending order. There's some way of doing it, it's like colon colon -1 or something, and we're going to need that for the spiral matrix one as well. So if nums1 at I is less than nums2 at j, then final R, we're going to append the nums1 at I, and then we're going to increment I by 1. Otherwise, nums1 at I is greater than nums2 at I. Then we're just going to do final R dot append nums at j, and j plus equals 1. And this, I think, this is just O of log n or something. I'm not too sure what log actually is, but I know that sorting is O of n log n, I think. Python sort function time converts that, but log is logarithmic. I know that much, but okay, why don't we just ask ChatGPT? Python sort function. So sorting already. Okay. And log n, yeah. Okay. What does log n mean in time complexity? Okay, geeks for geeks. Always good to turn to that for programming. Space complexity. So logarithmic. Okay, so it's just. Oh, I see. This is very useful. O of n, O of 1, so that's constant time. This is linear. This is O of n squared. So, like, it's just. Well, I don't know how to explain it, but then you got O of n cubed, say. For example, if you had 3 nested for loops, etc. So AI will not replace you. Okay. So I think that's it. So let's get implementing it. I'm also going to take a picture of this one. So this is actually a pretty easy solution. Then we would just return final. Oh. Yeah, let me just take a picture of this one as well. Okay. I'll find another way of uploading the images soon. So first what we do is we split the array. But how do we split an array? I think this will be very useful for improving my Python skills. How to split an array into 2 Python base at a specific index. Okay. Split into. Oh yeah, it's that, isn't it? Okay, so we need to first find the value that's closest to 0. So find very closest to 0. How are we going to do this then? So for iron nums, no, let's do it in range nums because we need it for the. So for iron range of len nums, if nums at I is less than 0 and nums so nums at I is less than 0 and nums at I is greater than cur, and we do cur equals num. So it's already sorted, so elif cur is greater than or equal to 0, then no, so it'll just be cur, so then we would break so let's initialize cur here. So cur equals nums at 0 I equals 0. So else if, okay, so we're going to make a first array, nums 1 equals nums. So this is going to be until, is this inclusive? Okay, we'll have to hope it's inclusive now. Nums 2, I have a feeling it won't be though. No, it's the other way around. Okay, let me just run up bubble real quick. I always have the Robin Hood hash map link, which is about just 10,000 characters long. So it always takes a while to type in the URL. Just when you got the solution to these leetcode problems, it just seems so easy. But then when you first see it, it's just, yeah, it's impossible. But I think it's much easier when I actually, where's my connect fault code in here? So I'm just going to do some experimentation. So say we have -1 to 2, sorry, it should be 0. Okay, I'm going to paste in this code. This is why I sometimes hate Python due to its indentation. Okay, so into Python. What's wrong about? Print so nums1. Right, and then oh yeah, I forgot Python has automatic spacing. Oh, that's right. So this will need to be +1. Okay, yeah, so this is the functionality that we want. Right, so after we've got this, we need to reverse the nums1 array. How to reverse an array in Python? Is it just get? Why did I place my bubble? It's actually got some pretty good sponsors now, and I saw it was featured in the Prime again. How many minutes am I on now? Okay, good. Oh, my bad. I've given you the. Right, so after this, I want to print nums1. It was something like this. Okay, yeah, that is it. Nums1 equals nums1. It's a weird syntax, I don't know why it's like that, but at least it reverses it. So now I'm going to go through each array, squaring all the values. So for I in range, then nums1, I'll put in this. So nums1 at I equals there's also, I'm sure there's a better way of doing this as well, but nums2 I. Okay, so now we squared them. Now we need to merge. So let's see our code here. So equals 0, j equals 0, final r equals. So while I is not equal to then nums1 minus 1 and j is not equal to then nums2 minus 1. Final no. Okay, so this is if nums1 at I less than nums2 at j, then final I'll append nums1 at I okay, nums2 at j. Yeah, we also need to I plus equals 1 and j plus equals 1. We can check if I is equal to then nums1 minus 1. then we want to append the rest of for x in, what will it be? It will be nums, so we want to append the rest of j. So nums2 would be like that. Final r dot append x if lfj is equal to nums2 minus 1. Then we want to go for x in yeah, this would be I plus 1 final r dot. I know there will be some just like one line function that could do this, but that's how it is. Return final. Will this run? With the better solution. Okay, and I used my, like in leetcode you can get one, oh no. Time limit exceeded. And then we'll have to append, no, this will be I equals nums at 1. And we have to do the same for j. All this finally be it. It's not seeming like it seems like it will time out. Time limit exceeded. This is the first input case. Okay. Well, I'm going to submit it. I know it won't work, but the thing with leetcode is it only stores it when you've submitted it. And that's part of the reason why my acceptance rate is so low. But with the 0, okay, output. I don't know why I'm missing them. Am I incrementing the wrong one? No, I don't think I am. Okay, we may come back to this. But yeah, we've got most of the code. Actually, no, why not? I just paste this to GPT. Now, please. This is literally the exact same as DeepSeek now. Anyway. The merge is suspicious. Wow, that's quick. Square them and in reverse order with the right part. Okay. Okay, why don't I just replace all of this part with I is equal to len nums 1, then final r dot append numbers to j plus equals 1. So this would be L of j is equal to then numbers 1 minus 1 probably not as efficient, but I mean I think it's much better. Wrong answer. Okay, at least we're getting a wrong answer now and not 14. So why am I missing out the minus 4? It seems we're always missing the first one. I don't know why. Why wouldn't this work? Because this one will always be at the end of the negative array, but we're not adding it. Okay, control, oops. Okay, first I'll replace this, because this is the same logic, it's just... This is the same logic, but it just prevents any further unnecessary still don't see it working though. So this is numbers 1. Yeah, number 1. So let's call it that. Comes 2. This is basically the same though, but merged. Alright. Final because this is just the same code, so it will not work. Let me see what else it changed. Else. To be honest, I can't see what it's actually changed. Oh yeah, you should use enumerate. Let's just change this to an else and see if this is going to be the source of our trouble. Because we're always... Oh, okay. Oh, we have a problem, don't we? Why are these... It's always the... It seems like it's the last of this. Okay, we'll just come back to this one. Let's go on to the next one. Okay, best time to buy and sell stock. Best time... What number was it? 121. Okay, actually, thinking about it, no, I was thinking it might be at like the mountain problem, but let me see if these pictures are uploaded. Nope. Right. Then maybe on my Google Drive or something. There. 1, 2, 1, 2. Let's time to buy and sell stock. Right, so we basically have an array of integers where we want to see which day will maximize our profit. No, which 2 days will we buy will max. Okay, we've already got the solution here. So I'm still gonna run through it. So 7, 1, 5, 3, 6, 4. And we want to buy on a day and sell on a day where our profit is largest. So I'll walk through this one. So basically we start off with our smallest value. We're having shouldn't this be, no, it should be infinity, because any value will be lower than it. Okay, so what would happen if you did float INF plus 1 less than float INF? Why don't we try this out? Print float INF plus 1 is less than float INF equal to. Okay, so it does. It does actually have the correct definition. So here we're having our maximum profit is 0, and we're going through each of the prices. So for I in, well, I'm going to say nums here. So if I is less than the smallest value, we're going to assign the smallest value to I. If it's not the smallest value, then we're going to look for the profit, and if it is, we're just going to set the profit. So if I is less than smallest equals I, elif I minus smallest is greater than profit, max profit, sorry. Because this is simply just O of n time. It's pretty good. So else if I minus smallest. You can also solve this using the 2-pointer technique, I think. But surely by that time it would just be O of n squared. Because, I mean, yeah, there would be no point in sorting it, because what's the point? You lose the order of the... Okay, max profit equals I minus smallest. Then we just return maximum profit. So this is a pretty easy solution. There's nothing much hard about that. So yeah, I'm happy with that one. Just here for reference. Just need to pause the video. Oh, number of islands. This was tricky. Number of islands 200. So right, so basically what we need to do here is some type of finding algorithm, like searching algorithm. So for example, breadth first search or depth first search. So basically I'll just draw out the grid here. So it's 1 1 1 1 0 0 1 0 1 1 0 0 0. I think it's actually so useful to just draw it out. Okay, so using the breadth first search, we have two lists. So it, I probably will need to go back to it, but I actually think I did this in Advent code. Let me just go to my GitHub real quick. Code. 2024. So it's day 16. Advent code is actually pretty good. It's just like leetcode. 16. Oh, I think this was it. Let me go to Advent code. Should be day 12. Yeah, this is it. Garden groups. So I kind of implemented breadth first search, but it wasn't a very good one. You can see how many lines it took me. And I can't remember even if I got it right. But it was definitely a good learning option because I hadn't really heard of depth first search before and I implemented it from scratch. But let's try and do it again. So we want to have our value here. So we've got our, let me go back onto leetcode then. So we've got our first value, top left, and R1. I'm just going to need to do some experimentation with this because I can't exactly remember how to implement it. So we're going to look at this one. If it's 1, if 1, and then we carry on. So we're going to look at this one. Oh no, so we're going to store so the curve pos equals this will be 0 0. So then we want to look at all the ones around. Yeah, it was literally exactly the same as the number of allotments. Okay. So let me just look through this. So we have the current pos, and then we're going to have an array of arrays. So would we find all the positions of 1s? Okay, this might not be the way, but I'm just trying to do some experimentation. So for I in grid, for j in I, if grid at I at j is equal to 1, pos is no positions. Then we're going to append I and j to it. And then we're going to check, once we've completed our breadth-first search, we're going to check, okay, no, it'll be fine, so I'll explain it when I get to it. So, first of all, we initialize it to the first one. Curve equals positions at 0. So we have this one. And then we have R1 equals, right, so we have a first position, which is 0, 0. Then we're going to branch out, look, north, east, south, west, basically. So we'll look to our north, and we can't do. North is not, but east is, so we're going to append this to our array, so of searched. So I'm not going to call that R, I'm going to call it searched. So it will be yeah, we like that. And then we want to look so south, and then there is, and when we're doing this, we also want to append this to our stack in calling them. So this will be search. This will be 1, 0, 1, 0. Okay, so now that we've found this one, well, then we look west, and it's not there. So here we found this one. Now we're going to go. We're going to pop off it from. Should we call this stack? Okay, let's call this found here. So our stack, and then we'll set the current pos equals stack.pop. So this takes the last value off the array and returns it. And then we'll do the north, east, south, west. So north. So then we would check if this position. So if north not in found, but is already in found. But if it's not in found, then we'll append stack.append. This would be, well, I'm just hard coding at the minute, but when we're implementing it, we can change it. So this will be not. Else, if we have found it, then we do nothing. So this is the continue, I think, in Python, which is also in C++. But I can't remember the last time I used continue in C++. I've barely ever used it. Okay, anyway, so if it's not in already found, then we just append it in found. And we're also going to append it to found.append. So we'll get, okay, and then, so we look north, then we look east, so we found another one. So this will be added to the stack. So or it would be added to both. So this is 1, 1. So north east, and then we're going to look south, and we found that. So this is 3, 0. We're also going to append this to that. Okay, and then we look west, and we can't do that. So that's the end of that one. Then we're going to pop off the stack. So then cur equals 3, 0. We remove that. So then we're going to look north, and it's already in found. Then we're going to look east. We found another one. So this is 3, 2, 3, 2, 3, 2. Okay. East, south. We found this, and it's a 0, so we don't. Then west, we can't. So that's that one done. And then the last position here is 3, 2. And then so pop this off, and then cur equals 3, 2. Okay, so then we're going to keep doing this. So we're going to keep doing this until we've found all of the ones in this current island. And then we're going to remove all those from the positions. And then we're going to set the position. Okay, and then we'll increment the island count every time. So cur equals 3, 2. So then we'll look north. North is in search, so we don't do anything. Then east, south, west, so we add nothing. And then we're going to pop, so 1, 1. Okay, so north already, east, south, west, so nothing in that. So we remove that and we pop that. Then we've got 0, 1. And so then we look north, can't do that. East, okay, we found another one. So we're going to look at, so this is going to be 0, 2. So north, east, south, west. So okay, we're going to add. Then we're going to pop this one. So 0, 2. Try and do this pretty quick. Okay, so north, east. Okay, east we found one. So this is 0, 3. And then, okay, north, east, south, west, because there's no others. And we're also going to put 0, 3 here. Get rid of that one. North, east, south, west. The only one is south. So we're going to add, what is this going to be? 1, 3. Okay, and then we look at 1, 3, and we look at it, and if it's got none, we pop it off. So then when the stack dot length, or sorry, len of stack is equal to 0, then we need to remove all found positions from positions array. And then once we've done that, we're going to need to assign cur pos equals positions at 0, and then this process will continue, and then we'll keep, yeah, so that's how we do it. Sorry if it's quite hard to understand, but that's basically what we've got there. So now is the problem of implementing it. I mean, that's going to be pretty hard. So, oh, for some reason I got loads of McDonald's Monopoly stickers in my pocket. So, okay, I might just leave this from implementing because it shows I've got it and I've just walked through it, and yeah. So okay, on to the next one. I might also come back to that one, but we do need to fix this one because it's got muddling up the order somewhere along the line. Number of, okay, spiral matrix. This is actually pretty easy. I don't know how I didn't get it. What I was doing, I can't even remember what I was doing. It was, yeah. Well, whatever I was doing, it was pretty wrong. So, because I don't know, it was like, I was going like that, I wasn't accounting for, never mind, it's just, sorry. So let's go on Google. I'm so good at typing, Google. Okay, spiral matrix, what was it, 57 was it? 54. It's actually a really nice solution when you get to it. The only problem is that you've got to, or I'll tell you when I get to it. But I do really like, to be honest, I don't know which type of search algorithm that was. I think it was breakfast search, because yeah, this is the code I wrote, and it was not the finest code ever written. Okay, I'm just gonna remove all of this, and let's get our sample matrix. So spiral matrix 54. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to have our spiral, so it goes across, down, cross, up, cross. So I'm going to rewrite this. 4, 5, 6, 7, 8, 9. Okay, so what we're going to do is we're going to pop off the... Wait, is pop from the front? Well, we want to take off this. Take off. So then we would be left with... so if you can see that, we want to take off these, no, so this one here. We want to take off that. And then what we want to do is we're left with 4, 5, 6, 7, 8, 9. We're left with, so the next numbers in the sequence are 6, 9. So we want to take off these two numbers. And that would be, it's more complex, but it's not too hard. So take off. Then we're left with a square. So 4, 5, 7, 8. Then we want to go across, and we want to pop this, but we want to take it off in reverse. So this is using the colon -1, I think. So then we're left with 4, 5. Then we want to go on the up column here. So this will be, it will be like the taking off the 6, 9, but in reverse. So take off in reverse, and then we'll be left with 5. So we'll go back to the taking off the top row, and we'll just do take off using normal. And then, so this will all be in the while loop of so while matrix. So this while values are still in it. Okay, so now I'm just going to check the original solution, because I can't exactly remember how you take a column off. You do it within a for loop, and I'm pretty sure. So let's just take a look at this. Okay, so it's matrix. Okay, so it is from the start. So while matrix. Okay, and we append all of these. Append these two results. And then matrix, if matrix and matrix at 0. So at 0, this is going to be the top row. For line in matrix, matrix dot append line dot pop. So this is taking each line and then oh, this is popping. Okay, and then pop by default is at the end, and pop with the additional argument passed in is popping at the well, with 0 it's going to be popping the first array from it. Okay, and then we pop it in reverse order, so that's how you do it for line animate. Okay. So yeah, this is actually pretty simple, and it's like this. So yeah, moving on. So they're just getting easier and easier from here. So minimum time visiting all points. Oh, this was actually a pretty tricky one. I can't actually exactly remember how they did it. So while points. Oh, we're taking the maximum. Okay, yeah. So it'll be the maximum of it. Like, you can't just move the smallest amount and get there. It'll be the largest of the two. Yeah. So I don't think there's much point in going through this. One. How many numbers are smaller than the current number? So brute force, and then. Right, let me just. In the second solution, what we're doing is we're going through the sorted list. And then we're adding the value to the dictionary within the if it's not already in the dictionary. Then we go through the list that now in the dictionary, each value's index will represent how many. Oh yeah, this is such a cool solution because we sorted the list O of n. Is it O of n squared? Oh yeah, it is. Oh, is it? No, it's not. Why did I put O of n squared? Oh, because that was the one above. Oh. God, what am I doing? Oh, okay, so how are we doing for time? Hopefully it doesn't, like, the quality doesn't go away. Anyway, so what we're doing is we're sorting the nums using which takes of n log n. We're having a dictionary, so we're I and num enumerate. So what this does, it gives you the index and the value at the index in the array. So if the number is not in the dictionary, so dictionary at num equals I, then return equals, we're going for every number in nums, we're going to append the dictionary at that value, which will be the index. So yeah, it's such a cool solution. Sorry if it didn't make sense me going through it, but I'm sure if you just look it up, it will. Okay, so then. Yeah, these are just. Actually, find missing number, let's see. If I is not equal to j. Oh yeah, because there's going to be sort. Okay. Then we're just going to return j minus 1. Yeah. So that's pretty easy. So now I think I'll go on to learning some more problems, because now that we've gone through all of these, we've gone through a fair few. Spiral matrix, the breakfast search one, best time to buy and sell stock, sorted array square, and 3-sum. I think it's time to go on to some more solutions. So I don't know how I'm going to do it, but well, I might have to meet the thing. I don't know if I'll get copyright strike. Okay. LeetCode course. So because if you're watching this, I'm just going to be watching your video. Don't know if the audio will be. Okay, let me just look up the legalities of this. Can you play a YouTube video's audio on a YouTube video without getting a copyright strike? Okay, so right, I think I'll have to mute the. Actually, what if I just put it on my computer? No. Okay, I'm gonna just mute my mic, and I'm gonna watch the video, and I'll unmute at certain intervals. So. Okay, so basically the problem we've got here, well, I'm just going to write it down here. So, longest mountain in array, 845. So this is a medium problem. Okay, so we want to find the longest mountain in array. So a mountain is, well, it's basically a sequence of numbers where it increases and then decreases. So it's like 1, 3, 5, 4, 3, 2, or something like that. And then you've got to return the length of the largest mountain. So say we've got 2, 1, 4, 7, 3, 2, 5. I have a feeling this will be a two-pointer technique question, but we'll have to find out. So just going through this, so what if we, okay, let's say I is here and J is here. We go through this. I want to see if nums at I plus 1 is greater than nums at I, then we are increasing. Just trying to think the problem through, that I think it's quite a hard one. So then increasing equals true. Are there any duplicates? Okay, so there may be duplicates. But what happened? I don't know. So then else will be decreasing. So my intuition here is that we're going to have our value and see the value in front of it. If it's lower than that, then we'll set a variable to variable like bool decreasing, no increasing, sorry, and then we'll do it false. And then we want to check for how long it. Okay, I'm just going to go straight to the solution. I know I shouldn't do this, but I'm just trying to figure out one and not seeming to get anywhere.
It's a mountain. Return 0 if there is no mountain subarray.
Sorry, just any codes. I'll just. Wait, so I'm just thinking, what if we, instead of storing the values, we just store the differences between the two. So say 3 minus 4 minus 1 3. I still don't see if that gets me anywhere. Actually, it might, because so if, say we reduce the array to minus 1, 3, 3, minus 4, minus 1, 3. So we do that, and then okay. It says that it's probably easier than the other ones, but yeah, at the minute I can't seem to find the solution. Okay, so I've just read through the solution, and I don't know why I didn't think of checking with the peaks. But so basically what you do is you've got to, well, first of all, the first and last value of the array can't be peaks. So you just leave them out. So you go through the array. So for I in range 1, 2, then nums minus 1. Then we check if I is a peak. So if nums at I minus 1 is less than nums at I and it's greater than nums at I plus 1, then we've got ourselves the peak. So here we initialize I and j. Sorry. What should I call them? What does he call it? L and R. Oh yeah. L equals R, which is I. And then we're going to do so while L is greater than or equal to 0 and nums at L minus 1 is less than nums L. I'm pretty sure that's how. Yeah. Then we're going to do L minus equals 1. And then we're going to same for the right. R is less than or equal to then nums minus 1. And nums at R minus 1 is less than nums at R. then we're going to do max equals max val equals so max val would equal right minus left plus 1 due to the peak. I think that's it. Yeah. And then we return. And he said it was a very simple solution, and it was. I should have thought of peaks. Next time I'll need to make sure to spend more time just think about it.
7, which is the peak, that gives us our solution of 5, the length of a mountain range of 5, as we can see in the original question. So while left is greater than or equal to 0, and the current number that left is pointing to is greater than the next number, move L down once more. 4 is greater than 0, so we can move the left pointer down one more position in our array. Same is not true when comparing the 0th and the first index, so we stop there. We repeat this for the right side.
Okay, so I was just writing this down and like as how to solve it. So it's basically just peaks. And so this solution he was saying is Irvin squared, and the most optimized solution is still Irvin squared, but it reduces the amount of comparisons by a few. And now we're on to sliding windows, and we're going to do contains duplicate 2. I'm just going to get a book from my bag. Well, it's not a book. It was supposed to be a 90-page book, and it's just on GitHub for free. So. Okay, here it is. Clean code handbook. Just printed it off. And I want to see if it does have this contains duplicate. It doesn't seem to. I want to see if I've done the contains duplicate though. Contains sliding window approach. Given array, numbers return true if y is twice and return false. Oh, contains duplicate 2. Right. Let's see what's different about this one. It always just seems so simple when you got the solution, but okay, I've attempted this one. Yeah, such the what have I done here? Okay. Right, I'm just going to try to implement this. I won't be using a sliding window, I'll probably hash method or something. So, for I in nums dictionary I not in dictionary I is 1, else dictionary I equals 1. Okay, so now we've got this. So return dictionary What? Given an integer array numbers and an integer k, return true if there are two distinct integers I and j such that. Oh! Such that numbers I is equal to. Numbers I is equal to j. And absolute of I minus j greater than or equal to k. So we're going to go for each, for I in dictionary dot values so then we're going to see get all indexes of value I. Oh, sorry. Then we could just, well, this would be the brute force solution. So then we go through each of these two, and no, each of these ones, seeing if I minus j is greater than or equal to k. So for I in nums so if if nums at I is equal to, oh no, it needs to be j. If nums at j is equal to I, then we do r and j for, okay, I'm going to read through this. So once we got the x's for x and r, so this is just the brute force solution. If x minus okay, so absolute of, it wouldn't matter which way round we did it, right? So 5 minus 3 plus 2, then 3 minus 5 is minus 2. Yeah, it wouldn't matter. This is probably then cubed. So return true. Why can't Python just have lowercase? True and false. Okay, let's see if this works. The brute force solution. Okay, 2 of them have passed. Right. So let's see. So 3. Is less than equal to k. So let's say we take 3 here. So this is 1, 0, 1, 2, 3, 4, 5. 5 minus 2 is 3. Okay, no. Then 4 minus 1 is 3. So it's always going to be 3 here, isn't it? So I don't know how I'm returning true. Less than equal to k. Okay. Now I'm going to go through the actual solution. Okay, it says the sliding window technique. So I vaguely remember that when we did the ChatGPT course, we basically have a window and you just hit, just sliding window. But I'm going to go through the solution, then walking through it, because it's easier when we got one solution to go off, and then for future solutions. So yeah, I'm just going to mute. I'll put the debug scene on. And audio. Okay, so I've just gone through the solution. Well, I watched a video of him going through the solution. So basically, there's two solutions it's going to go through. But the first solution is we have a set, and we're going to go through nums, and our sliding window is going to be of length 3. Because, well, no, just walk through it. So we go through, we enumerate nums, so we get the index and the number. So if the number isn't seen, then we're going to return true, because that means we have two of the numbers in our set, so in the sliding window, and the sliding window will only ever be of length k. And then we're going to just, if it's not in scene, we're just going to add the num to the set. And then if the length of the set is greater than k, then we're just going to remove the first element in the set. Wait, no, it's going to be numbers I minus k, which is the oldest element. Because you pass in the value you want to remove. So I'm just going to write this down. So we have a scene equals set, then we go through for I num in enumerate. So if the num is in scene, then we're going to return true. Then we're going to do set dot add. Yeah, it is num. Then if then scene is greater than k, so that would be greater than the sliding window size. Then we're just going to do set dot remove at I minus k. Oh, numbers are I. It's not the index, it's actually the value. Otherwise, outside the loop, we're going to return false. Okay, I'm just going to go watch the other solution. Oh, I thought it was showing the same solution, but it turns out it was just, I think it was too small to view on my iPad. So I'm on the next one, so minimum pair difference. I'm going to try and have a go at that first before I go to the solution on that. Okay, minimum pair difference 1200. Oops. Is Duke.gil, is that a website? Yeah, no longer available. Okay. What about Goo.gil? Google. Okay. Yeah, they've brought up a lot of domains. Okay, so 1200 leetcode. Minimum absolute difference. So let's see if we can actually crack this before tells us. So given an array of distinct integers R, find all pairs of elements with the minimum absolute difference of any two elements. Return a list of pairs in ascending order. Each pair AB follows. AB are from R, A is less than B, B minus A equals the minimum absolute difference of any two elements in the array. Okay, so the minimum absolute difference is 1. Yeah, okay. Okay, and then list all pairs with difference equal to 1 in ascending order. Okay, so I'm pretty sure here the sliding window is going to be 2. Okay. And okay, so what if we sort the array? Okay, so what if we sort the array? So say it'd be 4, 2, 1. Wait, is my marker on me? Okay, good. So then we're going to sort it 1, 2, 3, 4, and then what if we change this to, and then we would change it all into the differences. So then we would. Okay, so we don't even need to sort it. What am I doing? So then we can add all the differences. So we have our sliding window basically. So we have 4, 2, 2, 1, and 1, 3. Then we find the minimum of these differences. Min differences equals yeah, so we get the minimum differences, so this will equal 1. So after we've got the minimum absolute difference, right, okay, so after we've got the minimum absolute difference, I mean, that would be pretty easy if we just had a sliding. So maybe if we do sort it, sort nums, so ij equals 0, and then 1. So while j is less than len nums, then we're going to do if nums so if nums at I, no, it should be nums at j minus nums at I is equal to, I'll call it ABSD, absolute difference. Okay, and then we do R equals R dot append nums at j. Okay, then we just return, no, sorry, I plus equals 1, j plus equals 1. Then we would just return. Okay, so I've got a solution here. I mean, that's good. So, oops. I'm actually venturing into some code wars as well, because I haven't done mostly leetcode. I hear that code wars is much easier compared to it, but I'm not sure. So we want to do first we want to get the differences, so we're going to do for I in R, no, so for I in range, then R, so I'm going to do it from 1 to len R, diffs equals dot append R at I minus R at I minus 1. Okay, then we're going to get ABSD equals min diffs. Then we're going to sort no, sorry, R. I'm not actually sure if sort of returns the array. Okay, so ij equals 0, 1. So for, we need to set the R. Nums equals while j is less than len R, if nums at I, sorry, it should be j, oh, can I be negative? Yes, we need to do the ABS. Oh no, wait. I'm just... I'm pretty sure I need to do it up here. Okay, let's see if it actually works this time. Okay. Oh. Why is it? How is it out of range? Nums at J. I don't know, how can it possibly be out of range when we're... -1? And I is less than len. Is this it? How is is it out of range? So we're incrementing I and j. What is it? J minus. Oh. My bad. Let's see. Okay. Oh no. How am I getting that? We're appending an array, so how could it be? Okay, anyway. Oh, yeah. Yeah, I might come back to this another time. Well, I will come back to this another time. So, yeah. So, thank you for watching this video, and I'll see you in the next one. Actually, no. Let's just ChatGPT. Now, please fix this. There's going to be some small bug somewhere, isn't there? So fine. So let's see what's much different about let's bring this down here. For iron range. Okay, so we don't need the while. So for iron range, then nums. What's wrong? Invalid syntax. Oh. Still don't. Okay, so it should be -1 and I, so it's increasing. At the end of the day, this is not too inefficient though. Okay, let me just comment this out and let's see if ChatGPT's solution works. And it does. So what's so different? Result.append. Ah. So this should be then orange. Okay. Okay, why don't we just try? Because these are both doing the same thing. Maybe SD. Was this the... I was returning... Oh, that was it. That was the reason why it wasn't working. I was returning R instead of nums. Well, that explains a lot, okay? And I'll submit this. Okay, it's, yeah, not the best complexity, but still. I'm going to add this to my leetcode. I know, why did I put M? What's this? 1,200. £1,200. Okay, yeah, I'm going to end the video here, so thank you all for watching, and I'll see you in the next video. Goodbye.